At the top of your paper, in big letters, right at the top of your paper, denominators cannot equal 0. Because denominators cannot equal 0. When you have a denominator, you are dividing by the denominator, and you cannot divide by 0. It destroys our whole entire mathematical system if you try to divide by 0. That means that this denominator cannot be equal to 0. That's why this is written over here. Every single one of our problems, we're going to divide it into two parts. What x can be equal to and what x cannot be equal to. This denominator cannot be equal to 0. So we're going to write that down over here on the side. And the first thing we're going to do is find out what x cannot be equal to. We're going to subtract 5 and divide by 4. And these are what x cannot be equal to. We're going to be talking more about what that means tomorrow and why x cannot be, well, this is why x cannot be equal to those numbers, because if I substituted a negative 1 in here, it would make the denominator equal to 0, and that is never allowed. Okay, this is what x is not equal to. Now we have to find out what it is equal to. You know that you can solve a proportion by multiplying by the cross product. But I want you to think about a proportion in a different way. Instead of doing the cross product, I want you to multiply by the LCD, least common denominator. I want you to multiply both sides of your proportion by the LCD. Now, of course, if you multiply both sides of the proportion by the LCD, this is going to cancel out. This is going to cancel out. This is what you're going to have left. So probably at this point, somebody is thinking, why did she tell me to do that? Because I get exactly the same thing as I would have gotten if I just did the cross product, right? But the reason I want you to do that is because are all the problems going to be this easy? This is problem number 1. They're going to get more difficult from this, and I'll show you why in an upcoming problem, why this actually, it looks like more work, but it actually saves you work. And so now we need to distribute and solve. Do I have any x squareds in this problem? Then all I have to do is combine like terms. Subtract the 9x from both sides. Subtract the 15 from both sides. Cancel, cancel. Divide by the 3, and x equals negative 2. Down here in your answer, the answer is not negative 2. The answer is x equals negative 2. X equals is part of the answer. X equals negative 2. This is what x is equal to. This is what x is not equal to. Next example. The denominators cannot be equal to 0. This denominator cannot be equal to 0. This denominator cannot be equal to 0. That's where I got these two not equal equations. Subtract 5 from both sides. Now, hopefully, by now, you can solve a problem like this in your head. If you can solve a problem like this in your head, this is one place where you can skip showing the work if you can solve that in your head. Hopefully, by now, we can start solving simple equations in our head. This is what x is not equal to. Over there on this side, we need to find out what x is equal to. We're going to solve this proportion by multiplying both sides by the LCD. Are you getting a little bit better at finding the LCD if the factoring's not too terrible? The LCD would be 2x plus 5, 11x plus 8. I'm going to multiply that on both sides of my proportion. I'll multiply it by this fraction, and I'm going to multiply it by this fraction. That's going to cause this part to cancel out and this part to cancel out. What do I have left? 11x plus 8 multiplies by 1. X multiplies by 2x plus 5. Distribute. Do you see the squared right here? That means that this is a quadratic equation. In order to solve quadratic equations, they have to be equal to 0 so that you can factor them. Have you maybe heard me say that 24 times? In order to solve a quadratic equation, it has to be equal to 0. This is not what I mean equal to 0. That's not what I mean. That doesn't mean just stick an equal to 0 out on the end. It means that I need to subtract this from both sides of the equation and subtract this from both sides of the equation. And now, what is this going to be equal to? 5 subtract 11 would be a -6. Now that it's equal to 0, the way you solve it is to factor it. The way you solve it is to factor it. And I started in my other class multiplying 2 times the 8, but there's an easier way. Do you see that all of these numbers are divisible by 2? So I can factor out a 2. So now, in order to factor it, I multiply the first number times the last number, and I have a -4. These are the factors of 4. I need numbers that are going to add up to get a -3. Which pair of numbers would add up to get a -3? So this is going to be 0 equals 2, x plus 1, x minus 4. So this is going to be 0 equals 2x plus 1, x minus 4, and now I need to solve it. So 0 equals 2, 0 equals x plus 1, 0 equals x minus 4. Can 0 equal 2? Not in this universe. This does not give you any answers. 0 cannot equal 2. So you're going to solve these. X equals negative 1. Add 4. And so I'm about out of room. X equals negative 1. X equals 4. This is another place where I would be expecting you to start being able to do some mental math, going from here to the answer without actually having to write this down. If you can figure it out without writing these steps down, that's perfectly okay. Questions? Now, I have a question. In this problem right here, I factored and solved it and got 2 answers right there. In this previous problem, I didn't do that. What's the difference? Do we have any x squareds in this one? I'm not going to factor that. I'm just going to combine like terms and solve for x. But when I have an x squared, that's when you have to make it equal to 0 and then factor it, and then solve your factors. So you see the difference? Okay, example number 3. To start off example number 3, I am going to factor the denominator. And that's where I get x cannot equal to 2 and x cannot equal to, x plus 2 cannot equal to 0. And so I solve both of these, and x cannot equal to 2, and x cannot equal to negative 2. Now, are we getting a little bit better about factoring something like that, x squared minus 4? This is the kind of problem where it's going to save me a lot of work if I multiply by the LCD instead of doing a cross product. The LCD would be x plus 2, x minus 2. X plus 2, x minus 2. And I'm going to multiply that by 6x minus 6. X plus 2, x minus 2. I'm going to multiply, the LCD is x plus 2, x minus 2. I'm going to multiply both sides by the LCD, and then what's going to happen? Cancel, cancel. What's left? Everything canceled out over here except that canceled out, and I have distribute. Do I have any x squareds? Any x squareds in here? I do not have any x squareds, and so I combine like terms by subtracting the 6x and adding the 24, and the 24's cancel, and so what is x equal to? Please look at problem number 3 on your homework paper, worksheet 14-1. Okay, This is similar to the one we just did. This denominator factors into x plus 5, x minus 5. The denominator cannot equal to 0. We're going to discuss that a whole lot more tomorrow. We're going to add 5 to both sides, and on this one we're going to subtract 5. So x cannot be equal to 5. X cannot equal to negative 5. Well, what can x equal? This is what x cannot equal. In order to solve this proportion, instead of using a cross product, we are going to multiply both sides by the LCD. We're going to multiply the 1 over x minus 5 by the LCD and the other fraction, because that's going to cancel all of that, and it's going to cancel that. And what do we have left? Over here we have an x plus 5 times 1. Over here we have x, and everything else canceled out, right? Do we have any x squareds? If we have x squareds, we have to make it equal to 0 and factor. If we do not have an x squared, we just have to combine like terms. But what happens when I combine like terms? What's x minus x? Can 5 equal 0? Never. And so there is no solution, or the solutions are none. That doesn't happen a whole lot.